Welcome to In the Open with Luke and Joe. I'm your host, Luke Shantz, and here's my co-host, Joe Seppi. And a big welcome to our guest, Holly Cummins. Before we get to our show, don't forget to like and subscribe. Thank you for joining us for another installment of In the Open with Luke and Joe. Today, I'm excited to bring you a conversation with Dr. Holly Cummins. She is an innovation leader at IBM, and our conversation is going to cover a variety of topics, ranging from sustainability and cloud-native development to the IBM Garage method. Before we welcome our guest, let's say hello to my co-host, Joe Seppi.
Hey, Luke.
Hello.
How are you, my friend?
Hey, Joe. How are you? I'm well. Thank you.
Good, good. So the weather is lovely today. It really is quite nice. I can actually see our pool guy is out there freshening up the pool. We're almost like really nice pool weather. It's beautiful.
So I think we're in the same sort of microclimate window this week. As some of you may remember, in past weeks, Joe and I are very close to each other, but the weather will be drastically different. I was in my garden this morning, and it was beautiful, gorgeous.
Nice. Yeah. I'm up in the woods, up in the corner, and you're down close to the water. It's very different, interestingly.
Something I wanted to mention regarding this is, we've been talking about microclimate, but I learned something new this week. There's actually nanoclimate, getting down to like meter scale. And this is really important in agriculture because where the frost happens could really vary depending on where there's tree cover, where there's not. And there's all this. I had a conversation last week with some folks from UC Davis, and they were talking about this and how they're studying it and I wanted to mention before we bring in Holly, there's a new Linux Foundation project that just launched this week called Ag Stack for Agriculture Stack. And it's going to be all about open source models and data and code for the agriculture industry.
Yeah, that's fascinating. Nanoclimates.
Nanoclimates.
They can't even predict, the weather very well already, but good luck. But I'm very curious about that. I'll look into the Ag Stack. Pretty cool.
So without further ado, let's welcome Dr. Holly Cummins.
Hey,
Holly.
I got all excited before we do anything. Have you seen the streams from Sebastian Blanc from
No.
Red Hat? He has this sort of house in France that seems to have this magnificent pool with these magnificent views. And so he now has started doing all his streams like from inside the swimming pool, and he'll sort of like come out and, he'll have like a microphone and, a keyboard, and he'll be sort of like half underwater. So I think, really must try harder, frankly.
Yeah, that's a grand idea. And like we said, Luke's not far, so we can, we're both vaccinated. They say we don't even need masks now, which I'm kind of a little hesitant on, but we could go out to the pool and do this and do it in style. Let's maybe next week.
We could do open pool party.
Yeah.
Out of the gate innovation. Thank you. Thank you, Holly.
That's what I'm here for.
That's great. Why don't we start off, if you don't mind, doing a little introduction, let people know more about you.
Yeah, so I'm Holly Cummins, and my job title is an innovation leader. And what that means is I sort of work across IBM. And if we've got a client that has this sort of need to innovate, and then we've got a client team that has a really cool solution, and they just sort of need like a little bit of an extra push to make it happen, or they just need like a few more ideas adding, or maybe they don't have any ideas and they just need, please, we don't even know where to begin with this. Let's get some, ideas together, then that's my job, is to try and make it happen, and to try and come up with the cool ideas, and then to try and get them actually out and happening.
Yeah, sometimes it's a few less ideas even that they may need.
Yeah.
Great.
That's one of the things about innovation, actually, is sort of never underestimate the power of a good idea in a different context, and reusing these ideas and sort of moving them from context to context, and sort of saying, well, in this area, this is incredibly boring, but actually, if we take it here, it's incredibly interesting. I think that actually is some of what's going on with the agriculture, is sort of taking the techniques that we would have applied to something else as business as usual, and realizing that in agriculture, they're new and they solve problems.
Yeah. Yeah,
That's so true. And there's another Linux Foundation project called Open Horizon, and that's exactly what's going on. They use it in factories, they use it in retail, and now, yeah, it's being adapted and being used for agriculture.
Cool.
Yeah.
So I would also like to let our audience know a little of your sort of your CV, because you have this very interesting CV. You know, you've been involved in Java, you've been involved in, you know, all kinds of development and product, and now you're in this innovation role. But you have a PhD in quantum information studies. Is that right?
It is, yeah. So I've got a PhD in quantum computing, which is actually why I joined IBM, because IBM has a huge history of doing quantum computation work. And so when I was doing my PhD, I met researchers from IBM, and I said, "Oh, that's kind of cool. I want to work where you work." And then, as it happens, I joined IBM, but I didn't end up doing quantum computing. I decided that actually I'd rather just program all day. So I joined IBM as a developer. And then I started out working on Java performance. So that was really sort of rewarding, because the JVM is so widely used that if you can make like 0.5% difference to it, then that's going to have a huge impact. And then when we're going to talk about sustainability in a bit, and when you think about it in terms of sustainability, those improvements again can have a huge impact, even though they're small. And then from there, I went and started working on Web3 Liberty, which then became Open Liberty. And then I wanted to see the outside world, and I wanted to see clients, and I wanted to see people who were using the things that I was building. So I switched and I joined the IBM Garage, which is a services organization. So we helped clients we helped clients take advantage of the cloud and sort of become cloud native, because there's a lot of ways to think you're becoming cloud native and actually not become cloud native. So we sort of try and teach the best practices and share what we think works and co-create.
Yeah, that's fascinating. I remember not long ago, a year or so ago, maybe a little bit longer, wanting to dive more into quantum and learn more about what we're doing at IBM and Qiskit and all the things. And I kept coming across your name, and I'm like, but wait, she doesn't work in quantum. What? So yeah, it's a fascinating trajectory. That's one of the things I love about IBM too. You meet people, and they started here, and then they've done this, and then they're doing this over here, and you know, it's kind of a long arc.
And we talk about diversity in teams being a good thing, but I think diversity in individuals is a really good thing as well. And so we talk about this sort of idea of being a T-shaped person, that it's our breadth that gives us our superpowers, and that if we know something from another domain, we can pull it in and solve a problem. Or if we have a weird little skill that doesn't come in handy very often, then one day it's going to come in handy, and we're going to be able to raise our hand and say, I know how to fix this.
Yeah, that's fascinating.
And I can imagine, you know, having the solid foundation in quantum, but then having all this experience in real production systems and working with clients. Now the time we're in now, the last few years and this next few years are such a pivotal moment where quantum is becoming real. I can see just, it's obvious to me, you're so poised to be able to like just come out of the gate and really help people use this technology effectively.
Yeah, when I did my PhD, the sort of, you know, the conversation that we had when we were getting tea and stuff was, will there ever be a quantum computer? It was definitely, it was like an if, not a when. And for really good reasons, because there's really fundamental physical reasons why a quantum computer is hard to build, because you have to have it perfectly isolated from the outside environment, and yet you have to be able to interact with it. And those two are opposites. You can't do both. But actually now they've kind of managed to do both. So, you know, we really were back at the sort of the physics level and the theoretical physics level, and it's jumped forward so much in the past 20 years. And now, you know, you can go and you can play with a quantum computer on the cloud for free, which is still slightly blows my mind. And the conversation that we're having now is not, will we build this thing, because we've built it, but how is this going to be useful? What problems should we use it for? What problems have we not even thought of yet because we assumed they were impossible? But now with a quantum computer, they move from intractable to tractable, and we need to change how we do business to take advantage of that.
Yeah, and it's interesting. I think we talked about this in one of the prep calls. Like when you were doing your PhD in quantum computing and you joined IBM, like quantum computers were in theory at the time, and then they became real. And then now, not only that, you can do, they're on the cloud and people can take advantage of them. Is that accurate?
Yeah, like most of my thesis I did in MATLAB because that was the only way that I could do it. And it was sort of, well, I think if we did this on a quantum computer, if we had a quantum computer, it might work out well. But
yeah,
we didn't know.
That's amazing. And I'm curious too, you have all that background, and then now you're doing innovation with the garage. Is it coming? I don't know if full circle is the right word, but do you see quantum on the horizon in terms of your innovative work at the garage, or how is that lining up at all now or in the future?
Yeah, so IBM is starting to work with businesses we talk about this idea of sort of phases of quantum. So we had sort of a theoretical phase, and where we want to get to is quantum advantage, which is when you can solve something on a quantum computer that you couldn't have solved otherwise, at least not in any reasonable amount of time, and it's genuinely useful. It's not sort of a theoretical, well, we couldn't solve this problem before and nobody would ever want to solve this problem, but we could solve it. It's when it's going to make a difference to your business. And where we are now, we talk about quantum readiness, which is, we're so close to that quantum advantage. And so we need to make sure that we've got everything in place, that we, as an organization, that we figure out what problems we want to be tackling, that we've got the skills in place, that we've got those connections, so that, because there's going to be an advantage for the first movers to take advantage of quantum advantage, which is more advantages than that sentence should have had.
You're on mute, Luke.
I love to do that at least once every broadcast.
Keep us on our toes.
Keep us on our toes. I added the link to this blog post about the quantum development roadmap, and I think we don't have to get too into the nitty gritty of it here, but it's fascinating. Sometimes I feel like we're working at it's like NASA in the 1960s, like the amount of change that is happening that we're right in the middle of. And as you mentioned, right before the pandemic lockdown, I went to a financial conference, and it was so interesting to hear from all of these industry players, exactly like you're saying, while it maybe is not in production today, they need to get ready now. They need to start investigating. They need to learn these things because, it takes, especially with mission critical systems like, say, financial industry or, materials and pharmaceuticals, you can't, just turn on a dime. You need to really prepare and figure out how to integrate these things. So such a fascinating time.
Yeah, it definitely does have this sort of feeling of a frontier or a horizon. And you sort of have an idea what's over the other side, but you don't totally know, and we can guess what impact it's going to have, but we have to see it really to see it.
Yeah, that's fascinating.
Well, and very much like open source, I think this is such a time for opportunity. Like what it is get involved. If you're, like you were saying, if you're a subject domain expert in, say, financial space, or like I was talking to a video game developer the other day, lifelong video game developer, very successful, so passionate about quantum, spends his, nights and weekends doing it. I just saw he posted he won a big hackathon, and it's, when you combine those things, now all of a sudden, he's going to be able to bring that to domains that, maybe wouldn't have. Someone who is maybe that physicist isn't necessarily going to know the things that he knows, and then you find that common ground. It's amazing.
Yeah, it's totally there's a couple of cool things going on. One is, unlike NASA in the 60s, it's all being done as open source because we know that's the most effective way to do things. So anybody can just rock up, make a contribution to Qiskit, make a pull request to Qiskit, move things forward. But then, as you say as well, the thing that we really, really need is the problems and the applications. And yeah, exactly as you say, a physicist, they're not going to know every problem in the domain of banking. They're not going to know every problem in the domain of gaming, of maybe even agriculture. And so when people are using these systems, we're sort of, again, we're going on the trajectory that we went with classical computing, but much faster. So we sort of have the equivalent of Moore's law, where we can see we're getting more computational power. But then in terms of the programming models as well, they're advancing really quickly. So a lot of times when we're teaching quantum computing, we sort of start at the gate level of, you could do this to the and that to the gate. But nobody, I don't think, except for sort of to learn it, really wants to be programming at the gate level. You want to be programming in your domain. You want to say, I want to do this financial regression model. I want to do this Fourier transform, whatever it is. And so we need people to be developing those libraries that make sense to people in a domain that then take advantage of the quantum computing. And I think we're not there yet, but, at some point, quantum computing is going to become, almost like a sticker. So it's, well, there's a quantum computer inside, but it doesn't make any difference to my user experience as someone who's taking advantage of the system. I just know it can solve my problem, and before I couldn't solve my problem.
Yeah, that's fascinating, and I encourage folks to take a look. You can engage with the quantum computer on the cloud today, so please go check it out. It's pretty exciting stuff. But I know there are lots of other exciting things that you want to talk about, like sustainability. So maybe we can dive into that.
Yeah, so I've been interested in sustainability for a long time. Like I mentioned, when I was doing the Java performance work, one of the things that made me feel really good about what I was doing was I could see there was this potential sustainability impact. But I think it's becoming more and more pressing as a conversation, and more people are talking about it, which is really good. And we're just, I think, on the cusp of, when we talk about the non-functional requirements of a system, for a while we've been talking about resiliency and scalability, and now we're starting to talk about observability and that kind of thing. And I think sustainability is going to be one of those illities that we just should be including in the conversation by default. And because if you look at the sort of the IT industry, getting sort of an accurate measurement of its carbon footprint is hard, which is one of the problems that we need to fix. But if you look even just at data centers, they use around 1 or 2% of the world's energy, which is kind of comparable to aviation. Aviation's around 2.5%. And when we think about aviation, we just sort of automatically think, oh, look at that, it's so environmentally irresponsible. But actually we're comparable. So we, for pretty sound sustainability reasons, I think, need to be doing what we can to try and bring that footprint down. And the thing is, a lot of it, it's not sort of, hair shirts and, making these really great sacrifices. It's things that we should be doing anyway. Like, maybe I don't need to have these servers that I'm not actually using, this hanging around burning cycles. Well, that's going to reduce costs, and it's going to reduce carbon. So why wouldn't we do it?
Yeah, it seems like there. I think with a lot of when you talk about sustainability and trying to do your part for climate change, there's small things, there's big things. You can get overwhelmed by the big things, but there are a lot of small things. And I'm reminded of, we as developer advocates and engineers have access to our IBM cloud, and we kind of have unlimited stuff, but once a month or so, somebody comes knocking and says, hey, make sure you spin down your containers and your clusters and all this stuff. And I mean, I think, like you're saying, simple things like that and being mindful of what you are using and what you're not using can really go a long way in the small term, but it all adds up, right?
I'm fascinated by this problem, actually, because it's one of those problems that seems like it should be really easy. And it is incredibly hard, because that experience that you describe, I've had the exact same experience in the garage. And I think every software developer in every organization has it, right? We want to learn a technology, or we're playing, or we're trying something out, and we spin up something, and then we've done it. So then we get excited by the next shiny thing, and we forget to turn it off. And then someone somewhere in manager land looks and goes, my bill is how much? And there's this sort of the steam coming out of their ears, and then they try and figure out how much of this is needed, how much of it can be turned off. And it's really, really hard. And every system we come up with doesn't seem to work. So, there's sort of the pleading emails is the sort of the first line of defense. We've all been there. I'm a bit horrified by my cloud bill. Could you please try and sort it out? Yeah. And then, there's sort of, I think we try tagging, and that seems like it should work, right? Because tags, solve a lot of problems. But then we have to come up with a naming scheme for our tag. Like, how do I know what tags I can delete and what tags I can't delete? And how do I actually make people remember to do the tag? Because this is actually still a manual process. And then how do I write my automation to go through and find the things with the tags and delete it? And it just, it still ends up pretty clunky.
Yeah.
And then the worst one, I think, is meetings. So we say, my emails didn't work, so I'm going to bring you all into a meeting, and we're going to sit here until our cloud bill is halved. And, everybody in the room is like, okay, I'll turn off my workload. Just let me out of the room. And then, and so we're seeing, innovations in this area, but they're slow. So, stuff like FinOps is and, GitOps, I think, can help. But, it's still emerging for what is such a big, expensive, annoying, and apparently simple problem, except that clearly it's not, or we would have solved it already.
It's funny that having a meeting to bring everybody in to bring down your costs is innovation.
Yeah.
Right.
I actually have a personal experience that really relates to this, and I'm both sides of this story. I'm the one who's perpetrating and the one who's cracking the whip. Is just my home electric bill. I'll have this studio, I have all these LED lights, and I'll have other rooms, and I'll be running around, and then maybe I'll just go to sleep, and then I'll wake up the next day and I'll come down and I'll be like, what was I doing? Because I see it. I mean, we see it in our own home electric bill. I'm like, and I'm like,
yeah, I don't know if this is a dad thing or whatever, because I know other dads have joked about it, but like my superpower is going around turning off all the lights. I walk around, why is that light on? Turn that light off. And when we moved into this house a couple of years ago, one of the first things I wanted to do was get solar on it. And so now I have a battery and I have an app that tells me how much I'm using and how much is from the grid and whatever. So now I'm like pinpointing things like, oh, that pool filter is not very efficient. I need to look at upgrading that. So yeah, it's funny how sustainability kind of comes into all this.
Yeah, the data is so important, because I think without actual numbers, we go on our intuition, and I think we all trust our intuition a lot, right? Because I'm a smart person, I must know, and we end up really sort of hyper fixating on something that actually doesn't contribute a lot, and then it's something that, like the kettle and overfilling the kettle, actually can be a huge drain, the biggest thing, but we don't think about it. We think about like, oh, that device, I don't trust that device. But as well, like, I think, I'm a developer. I love automating things. I've never seen something I didn't want to automate. And it feels like we shouldn't be at the manual stage on this problem still, right? Like, you shouldn't be wandering around turning off things after your kids. We should be detecting that no one's in the room and dimming the lights. And we should be doing that like in our houses, and we should be doing it in our infrastructure as well, right? Like, if this server hasn't had traffic for 30 days, maybe don't shut it off. Maybe that's because actually that was the thing that was, running the computation that was going to, in 60 days solve all of the world's problems. But, maybe send an email saying, by the way, do you still want that? Looks pretty boring to me.
Yeah. Yeah.
That reminds me, this past week I did a think session, and the topic was code engine. And I feel like this is a tool or a solution that actually gets to some of these problems, because it sort of is, it lets you do cloud native without having to worry about any of the cloud native infrastructure management, but you can also use it to run batch jobs. It's basically a functions as a service as well. So you can kind of get to that place of like, it automatically only runs things when it needs to run. And you don't have to worry about all the tags and rules. Because that was, I come from software infrastructure as a service, and like, just, I see why they created Kubernetes and why we got to this place, but it's still not that easy. And now we're finally getting to a place where we've got some mature tools like this.
Yeah, I think managed infrastructure and multi-tenancy, and that responding to demand rather than being always on, those three things are really, really important. And cloud and code engine manages to combine them, which is so cool. Because I've sometimes in the past, I've heard people talk about just sort of plain Knative as a solution, because that allows you to scale your workload down to 0. But the pattern I was seeing, which just sort of made me go, no, don't do that, is, we'd have Knative, but in order to run Knative, we'd need to spin up a cluster. So we'd have this whole huge cluster, and then the one little application in the cluster would spin down to 0 when it wasn't being used, but the rest of the cluster was still there, not doing anything because we hadn't sorted out our multi-tenancy. So with the managed and the multi-tenancy, that fixes that, and then you really do get the good benefit.
So this is like a perfect segue to the next topic, but I wanted to make sure that we shared your blog post here, because I think this is really important. Do you want to touch on this before we move over to the cloud native topic?
Yeah, I think a lot of what I write in that blog post, we've just sort of talked about, but I've got a bit more detail on like some of the factors that can make Kubernetes be inefficient. There's sort of like, I think Conway's law. We talk about it for architecture, but I'm sure it applies to your network topology and your cluster topology as well. And it's these sort of human factors that can then end up having that environmental impact. And it's got pictures. That's the biggest recommendation for it.
That's great. Yeah, so I would love to hear more about, you were saying patterns you're seeing in the space. So let's talk about cloud native. I know it's a hot topic. What does cloud native mean to you?
I mean, cloud native means so many different things. And I think when we were talking about sustainability just now, every time you said something, I said, we can automate that. There's a technology solution for that. And I think that's sort of, as techies, that's what we do. And I think we've done that a little bit with cloud native, and we've tended to focus on the technology aspects of cloud native. And we think, like, sometimes we even say cloud native and Kubernetes as if they're synonyms. But what I've been seeing is that a lot of organizations want to be cloud native. And so they try and buy cloud native, and they sort of try and install cloud native. But the sort of the why of cloud native is being missed, because the sort of the cultural aspects and the process aspects and some of those DevOps aspects aren't there. Mm-hmm. And so then it means we've kind of got all the kit, but we're not actually getting the benefit.
Yeah, it's hard to just kind of plug in cloud native,
Mm. And I think when we try and define cloud native, for me, I sort of think we want to kind of go back to the why and then frame it in terms of the why. And if we are getting that why, we're cloud native. And if we're not, we're not. So, and the why really is about having ability getting to market fast, really, and being able to get something from a developer's laptop to a user in a really short time. And then when you realized that maybe that time was too short and the developer has made a horrible error, that you can then get the fix from the developer's laptop to the user fast enough that actually it didn't matter, because your quality is higher than it would have been if you'd done it the slow way.
Yeah. Luke, did you have something?
Yeah, I was going to say, in the way this is coming together in my mind, you're explaining it, I feel like, especially from an enterprise standpoint, if you have existing business that you want to, migrate to the cloud, or you want to, the term that comes to mind for me is like app modernization, right? Where you're going to have this whole stable of tools and processes that you can use, cloud native being one of them, but you have to really discern. And this is why it's good getting with experts who know the space and have experience to help you figure out what is the right solution. Because some of the stuff, maybe there's a way of just, hey, we can containerize that, adopt some DevOps practices, and then, when we're developing this new thing, we're going to do that cloud native. But the process that you learn in say a migration or a modernization, those are going to serve that new cloud native development. Is this sort of making sense?
Yeah.
I was just going to say, I'd tee up a question here for you, Holly, because Luke was saying along the lines of what I was thinking as well. I'm curious, in terms of app modernization and perhaps migration, like, what are you seeing people doing wrong, and what do you think is perhaps the right approach when you have more of a legacy application that you want to be cloud native, native being the kind of tricky part?
Yeah, I mean, I'm going to sound like a broken record, but for me, that you have to figure out what problem you're trying to solve. And I think sometimes, again, this is something that all of us do, is we see things being done by others, and we want to be better. We want to be as good as we can. And so we sort of copy those, but without sort of stepping back to what problem that are we trying to solve. So, for example, I heard a story and it was a bank, and they were sort of quite well-established, long-established bank, and then they were sort of starting to suffer with competition from these newer, nimble competitors. And they said, what's going on? How can we fix this? And they looked, and they had this huge COBOL estate. And they said, our competitors are not using COBOL. They're using microservices. We can fix this. So they were hoping to modernize everything, rewrite it all in, more modern language, have it all be microservices. And we thought, great, yeah, this sounds like really good, exciting project. We can help you with this. And then they added our release board meets twice a year, every 6 months. So the point of microservices, the value of microservices is that you can release them independently. And the cost you pay for that is more overhead in terms of just the automation that you have to have and the testing that you have to do and that kind of thing. So if you're planning to release these things in a huge chunk every 6 months, you may as well actually just have them running in one process, and then you're going to save a whole bunch of complexity, which is going to give you more time to actually write a better application that's better for your users. Or if you're not going to do that, then you need to rewind, and you need to not start with, let me make my application distributed. You need to start with, let me figure out how I can build enough trust internally to release this thing without going through this really slow, heavy, infrequent release board. And that's what's going to actually make the difference to my customers.
Yeah, that's really interesting. When I worked at Adobe, I was on the Behance team, and they were acquired by Adobe, and we had already had at Behance like a pretty modern approach to CI/CD, and we're even building out our own tools to further facilitate that. And Adobe kind of recognized how we were doing things in a modern way, and they kind of elevated that team within Adobe, like, okay, help modernize the rest of our groups. And the first thing that we got was like a 3-page checklist for a Java deployment that took 2 days and had multiple people sign offs, and we're like, oh my God, this is insane. So yeah, those challenges are real.
Yeah, I worked on one of my first garage projects. We'd been brought in by a client who really, it was a similar thing. They could see that how they were doing things wasn't quite ideal and wasn't fast enough. And they wanted us to coach them and help them. But that change is hard because people, these processes are there because people think they're reducing risk. And in fact, they're increasing risk. But, making that mental flip is tricky. So we were doing full CI/CD and full automated testing and test-driven development and everything. And then when we went to release, we had sort of a similar, I think it was like 86 tabs in this spreadsheet. And one of the things was about how many of our tests were passing. And we were like, well, of course it's 100%, because if it wasn't 100% that were passing, the build would have broken and we wouldn't have got to this stage. There's no such thing as tests that aren't passing in the CI/CD world. But again, it's just sort of changing and updating those processes.
Yeah, well, I work on Node.js, and so that's 100% isn't always right. We have a column for flaky tests, but yes, I agree. But that like mental switch is really hard for people, I think, especially who have been doing it that way for a long time, to like think, in that previous situation I was describing, we were sometimes deploying like 80 times a day, and people were like, how do you not like break everything? But when you have a process and you have tests, that's what you do. And then sometimes you do break things, but you also have a process to, roll back a step and then fix it and go forward.
Yeah. And if you deploy that many times a day, you're so good at it that you can make changes really quickly. Whereas I think what we sometimes see in the other way of doing it is it goes out and it's not good. And then there's a real panic, and either we have to sort of, do something really horrible, like I'm going to, open a shell on the production system and I'm going to like patch by hand on the production system. It's like, no, just don't do this. Or, we end up with, it's going to take us 2 weeks of people working overtime and nights to try and get this thing out. Whereas it should be just a boring thing where we go, oh yeah, whatever. I'll fix this.
Yeah. And so good at it is typically tooling and processes, right? Or tools that enforce the processes. Yeah.
I wanted to mention quickly that we actually have a whole podcast series on app modernization. So if folks are interested in this, would be a great place to get started thinking about what techniques to apply. Because when we had our prep call last week, right after the prep call, I went and produced another Think session, and it was on Open Liberty, which we had just talked about. So I was like, this is so funny. And they said the exact same thing that you just said, which was, you know, there's this backlash sometimes you see on blogs and forums now where, oh, we're going back to the monolith for microservices. That's not the answer. And I think it comes back to, you know, we want to chase that new and shiny thing, but if it's not actually the right solution for that problem and you apply it, of course it's not going to work, right? Like why split up a monolith into microservices that you're just going to run all together like a monolith anyway? There's no point in that. So there's so many tools and techniques, right? There's refactoring, there's migration, but even if you're migrating, you're gonna like you said, you're gonna implement a modern CI/CD pipeline and testing, and there's ways of moving. It's like it's a journey, right? That you're never gonna fully get there, but you're gonna always just keep pushing in that direction.
And there's not going to be one answer for your whole estate, which is really annoying, because when you talk to an architect and you say, what should I do? And they say, it depends. You're like, that's not what I'm paying you for. Just tell me the answer. But it does depend, because some things in your estate, you only change them when you can't possibly avoid it, and it's running in a server under the stairs. And the right thing to do with that is to leave it alone and to not touch it. Whereas other things, either you're changing them all the time, and every time you change them, it's really hard, or you're not changing them, but you can see you need to be, and your customers are going, look, this is so annoying. Why haven't you fixed this? And it's like, well, because it's too hard to change. Those are the ones you want to, put in the microservices, put to the head of the modernization queue.
Yeah, it's interesting that you call it an estate a couple of times here, and we were talking about owning houses and whatnot, and if so much of my house and property needed updating, modernization, like I wouldn't take the whole thing at once. I would be like, okay, what's going to be the most impactful, and what's what should I approach first? That really makes sense.
Yeah.
I'm curious. So, oh, sorry, did you have something, Luke?
I was going to say, if anybody has any questions, I forgot to mention this earlier, please feel free to drop them in the chat. We definitely have a lot of chatter going on in the chat. No direct questions. There's actually we have a very funny audience today. They have lots of silly things to say, which I'm not going to repeat. But feel free, if you have any questions, we'll surface those here.
Nothing inappropriate. Just
nothing. No, nothing inappropriate. Just silly stuff.
I'm curious, the conversation we're having here around modernization, like what maybe, so it's funny, I've worked at IBM for like 5 years now, which I know is a small amount in the IBM world. A lot of people work here for decades. And, exactly. Multi-generational sometimes, which is fascinating in and of itself. But I don't know a lot about the garage. Maybe you could tell me more about the garage, what you do there, and how it applies to some of this work that we've been talking about.
Yeah, so the garage, so many things that when we talk about IBM, I sort of started by saying I love it, right? So like I love Open Liberty. I'm so proud of what we did there, and I love the garage, and I'm so proud of the garage. And it really started when we were sort of looking at the startup world, and we were looking at how startups were doing business, and we said, we have a cloud that's going to be really, really great for these startups, but they weren't necessarily, they weren't our traditional customer base in IBM. And we said, we need to change how we work in order to, sort of fit with these businesses. So we adopted a lot of best of breed technologies and practices. So things like extreme programming, things like lean startup, things like design thinking, and we sort of combined them together, which was quite novel at the time. And we said we're going to work in startup spaces. So we were in Galvanize in San Francisco, and we're going to work like a startup. And what was kind of interesting was startups went, that's cool. And wow, look, Watson could, really help. Let me work with you. But then a lot of the really large companies looked and said, wow, that's amazing. We've been kind of struggling to work in a modern way, and we're kind of getting bogged down by this old way of working. And we thought because we were a big company, we couldn't change. But IBM, we can see you're working in that way now. Can you please tell us how you did it with your scale? so that we can do it. So we started sort of working with a mix of sort of startups and large companies. And with all of it, we were really sort of working on web apps, the kind of the traditional domain of the cloud. But then we sort of, what we defined was, we called it the Garage method. And so it was, again, that set of practices. And then we realized that's not just for Greenfield. That's not just for a web application. It works really well for data and AI, because a lot of it is, the things that I've been talking about, like, start by trying to figure out what problem you're going to solve and what problem you need to solve before jumping to the technology. Well, you need to do that in data and AI as well. And again, people, I think, especially in data and AI, people forget, because it's so exciting. And you think, oh, I could make a data model. And we don't step back to say, but is that the data model that anybody needs? And then we realized, it's the same thing for app modernization. It's sort of, the opposite of those kind of greenfield web apps, but the principles were the same of, let's figure out whose life we're making better and figure out how to make their life better. Let's be really sort of radically incremental and iterative and, not do this big bang thing, because that's probably going to fail. Let's do these small steps that are going to succeed. Let's do DevOps, CI/CD. So all of these things, we just sort of kept expanding and realizing it worked to, in sort of various domains. And so now, sort of Garage in IBM, we do a whole bunch of different things. So we work with people who maybe haven't even bought anything yet, and we sort of say, let us show you how this can solve your problem. We have a services organization, and then we can sort of do these big transformations as well, to say, I've got a big company and I need to change a lot of things. So this is a different scale than just one team, but Garage can help with that as well.
I was going to say, that's so interesting. And it makes sense, because it's so, like, the whole history of lean and that sort of methodology, right? If you trace it back, it's like the Toyota method and Deming and all of this. So it came from the big org, got really popular, adopted for the small, and then comes full circle. And the other thing I was going to say, I come from startup background as well, and I think what's so cool about IBM Garage method to me is it's like a full stack, right? Like, we think about full stack in code, but this is like full stack all the way through design, and I think that's so important, because almost, my own startup failed, but almost every startup I've ever met that failed didn't fail because their product didn't work. It did work. It was a product market fit. It was the team. It was other factors. So when you approach it from the IBM methodology, you're getting all of these factors, everything, right? And that's why I was like, I'm so smitten with it.
And I think, like, one of the things that we've adopted from Lean Startup is this idea of, like, let's try and figure out what our biggest risk is, and let's do that first. Whereas I think we have a natural tendency to put the riskiest thing off for last, and we'll say, I've got a really great idea. This is really great technology. Let me do all this first, and then at the end I'll go try and figure out if anybody wants it. It's like, well, no, let's try and figure out if people want it and if this is the right thing to do first. And I think we do it sort of in terms of our architectures as well. There's sort of this really natural tendency to say, I'm going to do all my plumbing work first. I'm going to do all my infrastructure work first, because I know I can do that right. And it's going to make me feel really good to have this solid infrastructure. But it's like, well, there's no point in having a solid infrastructure if there's nothing on top of it.
Which, that's actually what you just said perfectly relates to this question we have from Facebook, is how do you deal with / anticipate things out of the developer's control? For example, server, OS, kernel updates that affect the developer's app.
I think with that, there's sort of you probably want to divide them into two buckets, and you need different coping strategies for the two buckets. One is these sort of, so it's the sort of the known unknowns, right? Where you say, I can probably anticipate that this might happen. I don't know when it's going to happen, but because I can anticipate this, I try and front load that risk and either put in place a system to handle it as an early thing, or try and do something to make sure it doesn't happen, or that kind of thing. But then on the other side, there's going to be things that you just didn't anticipate. Maybe you made a mistake, maybe you couldn't have anticipated, but either way, they're just going to come out of the blue. So then there's where you really need this sort of the resiliency. And so you need to, and and you can sort of do resiliency in a few ways, and I think they're all really important. So one is like what we were talking about with the bad release. You need that kind of CI/CD DevOps resiliency where if something goes wrong, you can get a fix out without even breaking a sweat. And then you need your team resiliency as well. So one of the things that we do is pair programming, and we do that partly because it's sort of a built-in code review and it catches problems and improves code quality. But the main thing that we do is there's this idea of staff liquidity, which is if we have just Bob and he's the only one who can handle it if a kernel update happens and Bob goes on holiday, then the rest of us are in trouble. So we need to make sure that Bob is pairing and sharing his knowledge so that maybe the rest of us aren't going to be as good at Bob at handling the updates, but we can kind of do enough so that we don't have a catastrophe. And so there's sort of the people resiliency, which comes through doing multidisciplinary teams, full stack development, pair programming, the technical resiliency, which comes from optimizing for tight feedback loops, and then as well front loading the risk.
Yeah, that makes a lot of sense. I've worked at places with a Bob.
Yeah, I mean, everybody's had it, where it's like, don't touch that code. He's the only one. Anytime any of the rest of us touch it, it's broken for 6 weeks.
Yeah, but I've seen it too in terms of like the CI/CD stuff and just containerizing applications and being able to repeat your deployment steps, staging, QA, testing, and all those things. And then if you do have to update one thing, whatever it is, whether it's deep down or just in your application, you have a process and it's repeatable. And then you also can roll back if it doesn't work. All these things kind of fit into that, I think.
Yeah, one of the things that we always say is never do anything manually. It's got to be automated, and never do a fix until you have a failing test that reproduces the problem, because otherwise you can get into these sort of like kind of fishtail, like a car fishtailing, where you sort of veer from catastrophe to catastrophe. So you fix the one problem, but you don't write a test for it. And then the next problem comes along that was created by your first fix. And so you fix that, but then that regresses the first thing because you didn't have a test for it. And so then you just sort of yo-yo between bad situations, which doesn't make anybody happy.
Yeah, absolutely. I mean, I don't know if I've thought about it in the same way, but always like if something's broken, write the test for it and then fix it. And then, you're covered. Yeah, for sure. I'm curious too. Do you see the garage within IBM like growing and the usefulness of it? I mean, obviously it's very useful, but like the I don't know if influence is the right word, but do you see it expanding and growing?
Yeah, it's growing both in terms of size and in terms of influence, which is really nice to see. So they are hiring loads and loads at the moment. Should anybody want to go look that up? But as well, leaving in, not just in terms of the numbers, but in terms of how so many organizations are looking at what we're doing and seeing how well it works, and then adopting. Either sort of turning into a garage themselves. So now there's sort of, lots of different, garagey organizations across IBM, or, independent of the name, just sort of picking up bits of the method and saying, yeah, that really does work.
Pop that up there for folks who want to check it out. I is the concept expanding? Like I've correct me if I'm wrong, but like technology garages, or is that related in the same sphere? What's going on there?
Yeah, so technology garages, that's sort of a pre-sales facet of the garage. So that's again, we sort of, because we were doing really good stuff, but people had to pay for it. And then we sort of said, wouldn't it be cool if we could have a bigger reach by doing this, without necessarily having to have, like that sort of services contract in place, because people are going to get a lot out of this.
Yeah, that makes sense. I know we've talked about open liberty a few times, and it's something that we wanted to make sure we touched on. And I'm looking at the clock and realizing we should switch gears and chat about Open Liberty. Tell me about what you've done there and what's happening at the moment.
So Open Liberty is probably a really good modernization story, actually. I hadn't thought about it in that way until just now. But what Open Liberty was WebSphere Liberty was hugely successful for IBM and was used by lots and lots of our customers. But it was large. And for the ops experience was really great. The developer experience was large, which is not necessarily what you want on your laptop. But we couldn't modernize it because so many people used WebSphere that we couldn't just say, hey, I've got a better, newer WebSphere, because people would be like, but I was using the old one. I can't cope with that change. And they shouldn't have to. So then we had this sort of challenge to try and figure out, well, how do we completely change it and make it miles better without changing it at all and without breaking anything? And we worked out that what we could do, the things that people were actually depending on, was the sort of the programming models and the APIs and those external libraries. So we kept all those the same, and we had them in little OSGI modules. And then we changed the sort of inner core to be much more dynamic. And so we saw things like it would start in 3 seconds, which certainly traditionally, no application server had ever started in anything like that time before. So we could run it on a Raspberry Pi. And again, at the time, it was inconceivable, no matter who you were, that you could run an application server on a Raspberry Pi. But it was so small and it was so fast. And the problem that we were solving was developer experience. And this is actually one as well where I'm going to contradict myself, because, I say you've got to know what problem you're trying to solve. But sometimes you solve a problem that you weren't trying to solve, because it turns out that, we'd optimized it for laptops and developers. So it was, it started instantly, and it was, tiny footprint, and that was great for developers. And at the time, the cloud was just sort of starting to emerge. And it turns out that's exactly what you need in the cloud as well. It's so sensitive to footprint in a way that it's not if it's on-prem in a data center. So it turns out that, Liberty was the version of WebSphere that was really appropriate for the cloud. So as everything moved into the cloud, it ended up being Liberty, really sort of took over there. And then sort of reflecting the success of Liberty as well, it was open sourced, which, was really nice. And again, it was sort of, this is too good. We don't just want us to be, using it and developing it, and we want community contributions. And we also want it to be that sort of friction-free access where developers should just be able to use it without having to, worry about contracts and stuff. You should just be able to use it.
And that's interesting. So I'm not as familiar. So correct me if I'm wrong. So it's now a little bit more componentized and probably a little bit easier for developers to get involved into different areas of how it's structured now.
Yeah. So the sort of the big change, there was sort of two changes. One was that we componentized it, and that made it was a performance statement, and it made it more dynamic, and it reduced the footprint, and then it carried on like that for a while as WebSphere Liberty, and then we made another big change, and we it went from WebSphere Liberty to Open Liberty, and it was open sourced.
Yeah, when I say developers, I'm thinking about open source folks who want to get involved and help to improve and such.
Yeah.
Interesting. Okay. Sorry, I'm looking at the website.
I wanted to mention, I just asked Jon if if you answered her question, and she said yes, you answered a question. That the 2 bucket explanation really helped. So she said thank you. I wanted to ask too about when you were working on Liberty, it was closed, and then now it's been open. So now you've gone probably back, and you can probably you probably still have contributions in there. What was that? I heard a story from Brad Tobel about the Eclipse folks when they worked on it. They were like really kind of upset when it became open, because they thought they were making this like proprietary thing. What was that experience for you, like working on some proprietary that then became open?
I was so happy when it became open source. There's a little bit of a scary thing when things become open source that weren't intended to be open source, because all of a sudden your code is visible to way more people. And I think every product, there's all the stories, isn't there, of like the comment, that was never intended for more than a small audience, and now all of a sudden people are going, why does this line say this never works and should never be released? It's out there. So I didn't have any of that in my code, but it was really nice, because so much is open now, and there's so much vitality about the open source community, and so being able to sort of see my stuff out there and see my stuff being used sort of on the community is really cool.
That's cool. What you see anything on the horizon in the future, Open Liberty, that's exciting?
So it's really sort of gone now with microprofile. So there's sort of so much activity around microprofile and bringing in, a lot of things that you need in a modern server, like that, a lot of the observability and that kind of thing is coming in via the microprofile standard rather than by the JEE standard. So there's, lots and lots of vitality in that community, which is nice.
Yeah, very cool. Very cool.
So if there's any other questions, but we are getting close to the top of the hour, we probably could fit another question in if we get one through, but no pressure, folks. And I will add the link to my microprofile in case anybody wants it. But we are getting close. Since we are getting close to the end of our time, Holly, do you have anything we didn't discuss that we should have, or anything that we didn't ask that we should have?
You have a movie coming out or anything?
No, we were talking beforehand, because I do have a book, but it was written before I started working on Webster Liberty, and it's about the power of OSGI. And OSGI is the technology that made Liberty so fast, and it made it so dynamic. But I think it's a fairly niche subject, and the book was a while ago, so I think we probably won't be sort of beating down the doors of our local bookstore for it, sadly.
I will share the link.
But you can share the link anyway.
Yeah. Let me pop that up there.
Well, thank you for adding it, because I had actually had it there and then I deleted it. So I'm glad that you brought it
We're
back.
looking for it. Yeah.
There we go.
That's funny. Cool. Well, what anything we want to wrap up on?
Oh, actually, I've got one other thing. Unfortunately, I don't know if we have the link, because next Tuesday, I've got a webinar on IBM Cloud TV. I don't know what it is.
Expert TV?
Yes, thank you.
Let's see if we can find
How
the link.
unprepared am I?
I think I might have it here.
Yeah, it's with Dana Price and Dwight Ford, and it's about the why of modernization. So we're going to be doing a lot more of sharing some of those stories of here's good reasons to do it, and here's reasons why you really shouldn't, and you should have just done something else a while ago instead.
I found the link, but it's maybe not an easy one for folks. We might have to tweet that one out. Oh, hang on. Actually, I have IBM Biz Expert TV. Let me just pop that up. Oh, dang it. Now the page went the other way.
And
sorry, I only remembered it when we started talking about modernization.
Yeah, no, that's funny.
That is, at least I'll put the title up so it makes it so people can have a reference there. And it's funny, that was the Think session that I produced was Dana's session. So that's where I had the, where they were talking about microservices and sort of the misapplication of them sometime.
I've got a new party game, though, which is I can come up with lots of really obscure things to reference and watch you two sort of scramble to try and find the link to put it in.
That's fun.
Well, you're welcome back anytime. So, you could come up with some obscure things and then just, yeah, we're here for you.
Yeah. Super. Well, this is fun. Thank you.
Yeah, thank you for joining. It's been really great talking, and I feel like we could dive deeper on any of these topics, which would be fun. But we'll save them for another time.
Cool.
Thank you for tuning in.
Yep.
Bye.
Thank you.